What's the largest planet in the solar system? If you say Jupiter, you are correct. However, the planet is not just huge. It contains lots of mysteries that have been fascinating scientists since its discovery. Thanks to multiple spacecraft visiting the planet, we've expanded our knowledge of the jumbo planet significantly. What have scientists recently discovered on Jupiter, and how did the discoveries affect the Sun and our own planet? Jupiter is as massive as planets get. In fact, the planet is used to describe other large planets in the universe. Just how massive is this planet? Well, Jupiter is 318 times more massive than planet Earth. And if that is not impressive enough, Jupiter is 2.5 times more massive than the rest of the planets in the solar system combined. There is one interestingly ironic thing that scientists have discovered about Jupiter. If the planet gets larger, it will actually become smaller. How come? Well, additional mass would actually make the planet denser. This would cause it to start pulling it in on itself. However, astronomers estimate that Jupiter could grow to 4 times its current mass and still remain about the same size. Apparently, Jupiter has found a unique solution to its weight problem. There is something else about Jupiter's mass that is fascinating. While Jupiter has a lot in common with stars, it cannot become a star. In fact, it is safe to call Jupiter a failed star. You see, like a star, Jupiter is rich in hydrogen and helium. The jumbo planet does not have nearly enough mass to trigger a fusion reaction in its core. In case you are not aware, this is how stars generate their energy. That is, by fusing hydrogen atoms together under extreme heat and pressure to create helium, releasing light and heat in the process. For this process to start, a potential star needs a huge amount of gravity. For Jupiter to reach this stage and ignite a nuclear fusion process and become a star, it would need more than 70 times its current mass. However, if you could somehow crash dozens of Jupiters together, you might have a chance to ignite a new star. But since that is not happening, Jupiter is not going all star on us and shall remain an oversized planet in the solar system. Jupiter is huge, but it's also bright. It is the third brightest object in the solar system after Venus and the Moon. Of course, that's not counting the Sun. Jupiter is big and bright, so much so that you can see it without the aid of a magnifier. In fact, most people have seen Jupiter in the sky, even if they don't know they're seeing the planet or mistake it for a star. In fact, with a simple telescope with a modest amount of magnification, you might spot some of its moons. Since you can see Jupiter, so could the ancient people before us. Jupiter has been known to humans for thousands of years. It's been featured in the mythological and astrological belief systems of multiple cultures. The planet was first mentioned in recorded literature during the Babylonian Empire between the 7th and 8th centuries BCE. History buffs will be excited to learn that the Greco-Egyptian astronomer Ptolemy constructed his famous geocentric planetary model that contained deferents and epicycles to explain the orbit of Jupiter relative to the Earth in the 2nd century. He even stated Jupiter's orbital period in his work known as the Almagest, that is 4,332.38 Earth days, or 11.86 Earth years. But Ptolemy wasn't the only ancient person to calculate Jupiter's orbit. Back in 499, Aryabhata, an Indian mathematician astronomer, also used a geocentric model to estimate Jupiter's period as 4,332.2722 days, or 11.86 years. The same is claimed of the Chinese astronomer Gandhi, who discovered Jupiter's moons in 362 BCE without using any instruments. If true, then Galileo was not the first to discover the Jovian moons 2 millennia later. But Galileo still gets the distinction of being the first astronomer to view Jupiter through a telescope in 1610. He also spotted the 4 largest moons of Jupiter, and they are known today as the Galilean moons. In fact, the discovery of moons other than Earth's was special because it was a major point in favor of Copernicus's heliocentric theory of the motions of the planets. As massive as Jupiter is, the planet consists mainly of gases. Needless to say, it is the largest of the gas giants. It has a gaseous outer atmosphere and an interior made of denser materials. The former contains between 88 and 92% of hydrogen and between 8 and 12% of helium by volume. You'll also find traces of methane, water vapor, ammonia, silicon-based compounds, benzene, and other hydrocarbons. Other gases present are ethane, hydrogen sulfide, neon, oxygen, phosphine, and more. The interior contains hydrogen, helium, and other elements in minute quantities. Scientists have discovered that Jupiter has a core that may be up to 45 times heavier than the Earth. Then there are the moons of Jupiter. Currently, scientists know of 79 moons attached to the planet. Nothing says more won't be discovered. The four largest are called the Galilean moons and are named Io, which is actually the most volcanically active body known in the solar system. Europa, which scientists have suspected, has a large ocean that may host life. Ganymede, the largest moon in the solar system, and Callisto, which may also have subsurface water. There is another group of Jovian moons known as the Amalthea group. They are smaller in size with diameters less than 200 kilometers and orbit the planet at orbits less than 200,000 kilometers in radius. They are Metis, Drestia, Amalthea, and Thebe. These moons, along with others, help Jupiter to maintain its rings. There are other irregular satellites attached to Jupiter. They are noticeably small and have larger and eccentric orbits. Scientists theorize these objects were formed as a result of collisions between larger objects and were simply trapped by Jupiter's gravity. In fact, the moons of Jupiter did send scientists on a wild goose chase recently. What happened? In 2017, astronomers searched for the theoretical Planet X. Something outside our solar system is tugging at objects within. As this could be the missing planet, scientists turned a powerful telescope in that direction. They did not find proof of a ninth planet, but the same patch of sky contained Jupiter. But where did the idea of Planet X come from? That takes us back to the early 19th century, a time scientists knew about all the major planets in the solar system except Neptune. Thanks to Newton's law of motion, they could predict the planet's movement, but they discovered that Uranus wasn't moving as predicted, and they began to wonder if it was an unseen planet pulling at Uranus and sending it off course. When Neptune was eventually discovered, they realized it was not enough to explain Uranus's weird movement. This led some scientists to suggest the existence of a ninth planet, which was named Planet X by Percival Lowell. The American astronomer built an observatory to find Planet X, but didn't find it before his death. Even the discovery of Pluto, which is no longer considered a planet, could not explain Uranus's movement. Some astronomers are still searching for Planet X. So back to 2017, when the astronomers were scanning a section of the sky containing Jupiter while searching for Planet X. Somebody had a moment of quick thinking and viewed the gas giant itself and noticed more moons. All told, the team found 10 new moons orbiting Jupiter, bringing the total number of Jupiter's known moons to 79. One of the new moons is quite the weird one. Jupiter's moons move in packs, and two of the new satellites spin with a group that rotates in the same direction as the gas giant. The rest showed up in a cluster that spun against the planet's rotation. This is what astronomers refer to as retrograde. The weird new moon was inside this group but spinning with Jupiter. Called Valetudo, it could have a short lifetime. Being an anti-retrograde moon within a retrograde cluster, a future collision is inevitable. Speaking of gravity, as the heaviest planet in the solar system, Jupiter has the most intense gravity. You will experience 2.5 times more gravity on Jupiter than on Earth. This gravity is so strong that it tore apart an asteroid known as Shoemaker-Levy 9 and sucked the broken pieces into itself. The asteroid was actually captured between 20 and 30 years before the impact and has been orbiting the planet since. But in 1992, the asteroid entered Jupiter's Roche limit and was broken apart by the planet's tidal forces. The asteroid looked like a string of pearls until its fragments impacted the surface in July 1994. The fragments were as large as 2 kilometers each and hit the surface at 60 kilometers per second. The impacts were a boon for scientists as they allowed astronomers to make several new discoveries about Jupiter. They were able to spot some chemical compounds that were not seen before the impact in the Jovian atmosphere. Among the new chemicals were diatomic sulfur and carbon disulfide. It was the second time the former was detected in any celestial object. It was also the first time researchers discovered ammonia and hydrogen sulfide on the planet. What is interesting, and at the same time scary, is that Jupiter's powerful gravity may cause serious problems for Mercury and the rest of the solar system. How? While the solar system may seem to be stable, problems could be brewing, and Jupiter is at the center of it. The problem is that Jupiter has a disproportionately huge gravitational influence over its siblings, and the smaller planets bear the worst of the effect, and they may actually be doomed. The huge gravitational pull of Jupiter seems to be bullying Mercury into an increasingly eccentric death orbit, which might end up flinging the lighter planet into the path of Venus. Considering we inhabit a neighboring planet to these two, things might not be so rosy for the Earth either. Jupiter orbits the Sun at a distance of about 748 million kilometers, which is 5 times further away from the Sun than the Earth. But that doesn't mean we are high and dry. Although this distance may be huge, this 318 Earth-mass planet's gravitational pull is very important to the inner solar system planets, including tiny Mercury. Mercury has an elliptical orbit around the Sun, bringing it as close as 0.31 astronomical units to the Sun and taking it 0.47 astronomical units away from it. 1 astronomical unit is the distance between the Sun and the Earth. However, Mercury is only 0.055 times the Earth's mass, or just 5 times heavier than the Moon. After running long-term simulations on the orbits of solar system bodies, scientists in France and California have realized that Jupiter's gravity may disturb Mercury's eccentric orbit even more. Their simulation predicts that Mercury's orbit may extend into the path of Venus, or it might just fall into the Sun. They claim there are 4 possibilities awaiting Mercury if Jupiter continues to exert a gravitational pull on it. Mercury will crash into the Sun. Mercury could be ejected from the solar system altogether. Mercury could crash into Venus, or Mercury could crash into Earth. The last option is obviously the worst-case scenario for us on Earth, but all will be bad news for Mercury. The small planet's fate appears to be sealed. But what happens if Mercury smashes into the Earth? It won't actually be the first celestial object to do that. However, the asteroid that most likely wiped out the dinosaurs when it impacted the Earth will seem like a drop in the ocean compared with a planet 4,880 kilometers in diameter slamming into us. In fact, there will be very little left after this wrecking ball impact. Hopefully by that time, Elon Musk would have gotten his Mars colonization effort underway, as that is the only scenario that humans escape and continue to exist. Sadly, even Musk's efforts may not save us, as the Sun is more likely to first turn into a red giant and swallow Mercury, Venus, the Earth, and Mars all together. Many people have younger and smaller siblings that they will protect jealously. However, that is not the case with Jupiter. Instead of being a protective big brother to the Earth, the jumbo planet actually puts us in harm's way. Using computer simulation, scientists have found the largest planet in our solar system's gravity hurls deadly asteroids towards us instead of keeping them away as previously assumed. Scary, right? A paper worked on by NASA's Jet Propulsion Laboratory suggested evidence shows Jupiter was not a protector planet, using its own gravity to suck asteroids away from Earth's path. Jupiter's gravity may actually nudge some asteroids toward the Sun, where they stand a chance of colliding with our planet home. For many years, our understanding of the relationship between the Earth and Jupiter has been shaped by the Jupiter shield theory, which says the bigger planet acts like a giant space shield due to its huge mass, which causes it to suck in or deflect dangerous debris. But now, thanks to the work of Kevin Grazier, the shield theory is slowly falling out of favor. He published several papers explaining why he thinks Jupiter is a sniper rather than a shield. Actually, the relationship is complicated because Jupiter sometimes protects the Earth by deflecting comets away from the Earth, but new evidence proves that it's just as likely to take objects that come nowhere from the Earth and flings them in our direction. Of course, comet and asteroid strikes on the Earth are no jokes. You can ask the 4 dinosaurs that went extinct. However, space is full of these dangerous objects, and the Earth needs protection, so it's important to establish whether Jupiter is a friend or foe. Interestingly, it took strikes by comets and asteroids on the Earth when it was young before all the ingredients needed for life were assembled, but they could as well wipe out the life they have created in a few seconds. Overall, Jupiter is our friend because it slings most of the comets coming from outside the solar system back out. There are even signs that it has taken hits on our behalf. While Jupiter may appear to be a big bully today, you may want to cut it some slack due to its childhood. A new scientific discovery showed evidence of a traumatic childhood. In 2018, a study found that the largest planet suffered a delayed growth spurt. Most scientists accept the solar system's beginnings start with the Sun orbited by a dust-filled gas cloud. Then pieces started to glom together into lumps, which then formed larger bodies that grew into the planets of today. Such a serene upbringing was not something Jupiter had as a kid. It was the odd kid out. At first, small clumps fattened the planet up for 1 million years. After ballooning to a stage where it could beat Earth's mass 20 times over, Jupiter's growth ceased. Suddenly, massive worlds smashed into the planet. However, instead of adding mass to Jupiter, they injected energy. This created zones with so much heat and energy that gas molecules struggled to merge with Jupiter. The bombardment continued for another 2 million years and ground the planet's growth down to a snail's pace. Even so, Jupiter grew to 50 times Earth's mass. After that stage, the planet gorged on gas and quickly swelled to its current mass, which equals hundreds of times more than the Earth's. The next discovery on Jupiter involved an event that scientists assumed was a comet strike on the planet, but turned out not to be so. What then exactly happened? From the Earth, astronomers noticed a flash that lasted only 2 seconds and was gone. They immediately suspected that the giant planet had been hit by something, although they didn't know how big the object was or how deep the atmosphere was penetrated. The next step was to begin searching for a black eye pattern left by former impactors, but they eventually turned to the Hubble telescope for help. But not even the telescope could sight anything, as there was no sign of debris. The implication after 3 days was that the object that struck the planet did not descend beneath the clouds and explode as a fireball. If that had been the case, the dark sooty debris would definitely have been ejected to rain down onto the clouds, so it was assumed the flash came from a giant meteor burning high above Jupiter's cloud tops. Even though Jupiter is massive, it is by no means a slow planet. In fact, Jupiter is the fastest spinning planet in the solar system. This is like the heaviest kid in the class winning the sprint races. Jupiter has a rotational velocity of 12.6 kilometers per second, or 45,300 kilometers per hour, which means it takes only 10 hours to complete a full rotation on its own axis. You know what that means? Jupiter will complete nearly 2.5 days before the Earth does. Jupiter spins so fast that it is flattened out at the poles and bulges at the equator. As a result, Jupiter's polar radius is about 67,000 kilometers, 10.5 times more than the Earth, while its diameter at the equator is 71,500 kilometers, 11 times more than the Earth's. This fast rotation contributes to Jupiter's powerful magnetic fields. In fact, scientists claim that should you lose your way on the planet, you can find your way using a compass, just as you can do on Earth. Jupiter has the strongest magnetic field of any planet in the solar system. This is likely due to eddy currents, or the swirling movement of conducting materials inside the liquid metallic hydrogen core. The magnetic field traps particles made up of sulfur dioxide from one of Jupiter's moon's volcanic eruptions. The process produces sulfur and oxygen ions that, combined with hydrogen atoms inside the planet's atmosphere, form a plasma sheet in its equatorial plane. The same high-speed rotation has another effect on Jupiter, this time a very dangerous one. The interaction of the magnetosphere with the solar wind generates a bow shock, or a dangerous belt of radiation that can damage spacecraft. Jupiter's 4 largest moons are all orbit within the magnetosphere, which protects them from the solar wind, but also makes the likelihood of establishing outposts on their surface problematic. The magnetosphere of Jupiter is also responsible for intense episodes of radio emission from the planet's polar regions. Now we will talk about Jupiter's moon Io again in the next discovery by scientists. How did this Jupiter moon, known to be icy, get its dune? Current scientific understanding dictates that dunes by their nature are hills or ridges of sand piled up by the wind, and scientists in previous studies of Io, while describing its surface as containing some dune-like features, concluded the ridges could not be dunes since the forces from winds on Io are weak due to the moon's low-density atmosphere. The clue to the answer lies in data that are getting old already. During the Galileo's mission from 1989 to 2003, scientists were able to gather data so numerous that up to this day, nearly 20 years after, scientists are still poring over all the data. It was from this pile that the insights needed to understand what is happening on Io came from, and it had to do with volcanic activities so strong that they are reshaping the surface of the satellite and creating the large-scale features that resemble dunes. So Io's surface contains a mix of black solidified lava flows and sand, flowing effusive lava streams, and snows of sulfur dioxide. The group of researchers actually used mathematical equations to simulate the forces on a single grain of basalt or frost and calculate its path. When lava flows into sulfur dioxide beneath the moon's surface, its venting is dense and fast-moving enough to move grains on Io and possibly enable the formation of large-scale features like dunes. After devising or duplicating the mechanism by which the dunes could form, the researchers checked the photos of Io's surface taken by the Galileo spacecraft for corroboration. The spacing of the crests and the height-to-width ratios they observed were consistent with trends for dunes seen on Earth and other planets. One of the wonders of Jupiter is the Great Red Spot. In fact, it is one of the defining features of the planet. This feature is an anticyclonic storm found on the south of its equator. While it appears small when viewed from the Earth, this storm actually measures between 24,000 kilometers in diameter and 12,000 to 14,000 kilometers in height. This is a storm you want to avoid at all costs. At this size, it is large enough to swallow 2 or 3 planets the size of Earth's diameter. One thing about the Great Red Spot is its longevity. It has been around for at least 350 years. This is because it was spotted for the first time in the 17th century. The credit for the discovery of the Great Red Spot goes to Giovanni Cassini, who saw it in 1665, although he wasn't sure of what it was. But by the 20th century, astronomers had begun to theorize that it was a storm, and that it was formed as a result of Jupiter's turbulent, fast-moving atmosphere. These hypotheses were confirmed when the Voyager 1 spacecraft had a close observation of the planet during a flyby in 1979. Since then, scientists say this storm has been shrinking. It has come down to its present size from about 40,000 kilometers based on Cassini's records, which would mean it's now half of its former size. Will the Great Red Spot ever disappear? Nobody knows for sure if and when it will do so. However, they are sure that another storm will form somewhere else on this vast planet. Now, if you have heard of the Great Red Spot on Jupiter, are you aware that there is a Great Blue Spot on the planet as well? What is the Great Blue Spot all about? It is magnetic. A team of NASA researchers, including Jack Conanay, came up with the most detailed map of the planet's magnetic field, and it revealed something spectacular. The map is compiled from data obtained from 32 orbits during Juno's prime mission. The group of researchers claimed their new map provides new insights into Jupiter's mysterious Great Blue Spot, a magnetic anomaly at the planet's equator. Juno data indicate that a change in the gas giant's magnetic field has occurred during the spacecraft's 5 years in orbit. What is happening is that the Great Blue Spot is drifting eastward at a speed of about 2 inches, 4 centimeters per second, relative to the rest of Jupiter's interior. At that rate, the Great Blue Spot will go around the planet completely in about 350 years. In contrast, the more popular Great Red Spot, the long-lived atmospheric anticyclone just south of Jupiter's equator that refused to die, is drifting westward at a relatively rapid clip, going round the planet in only about 4.5 years. Apart from this, the new map shows that Jupiter's zonal winds are pulling the Great Blue Spot apart. Zonal winds are jet streams that run east to west and west to east, which gives Jupiter its distinctive banded appearance. This means that the zonal winds measured on the surface of the planet reach deep into the planet's interior. The new magnetic field map also enables Juno scientists to make comparisons with Earth's magnetic field. The data suggests to the team that dynamo action, that is, the mechanism by which a celestial body generates a magnetic field in Jupiter's interior, occurs in metallic hydrogen beneath a layer expressing helium rain. In all of this, you may be asking if there is a possibility of life on Jupiter. Data from NASA's Juno probe indicates that about 0.25% of the molecules in the atmosphere over Jupiter's equator is composed of water. Let us save you the mathematical calculation and expression of that 0.25%. That 0.25% is based on a prevalence of water's components, hydrogen and oxygen, 3 times more than at the Sun. Amazing. Why this data is amazing and shocking was that NASA's Galileo data about Jupiter was different. After this latest discovery, scientists checked Galileo's result and compared, and they discovered something. What did they discover? They discovered that the result of Galileo's was drier than that of Juno.
Galileo's results sent back data showing 10 times less water than scientists predicted, and more weirdly, the amount of water appeared to increase the deeper the spacecraft went into Jupiter's atmosphere. It happened that at the same time Galileo was plunging into Jupiter, there was a ground-based infrared telescope that was able to measure water concentrations at Jupiter. This telescope showed that Galileo may have accidentally hit a dry spot during its probe. This could mean only one thing: water is not well mixed deep in Jupiter's atmosphere. This is also proven by Juno during its first 8 flybys. It revealed that there is a lack of atmospheric mixing on the planet and its surrounding systems. Juno principal investigator at the Southwest Research Institute, Scott Bolton, said in a statement, "Just when we think we have things figured out, Jupiter reminds us how much we still have to learn." He added, "Juno's surprise discovery that the atmosphere was not well mixed, even well below the cloud tops, is a puzzle that we are still trying to figure out. No one would have guessed that water might be so variable across the planet." Working with the results of Galileo's probe and that of Juno, scientists will be able to get more details about Jupiter, the Jovian system, and the solar system. Jupiter is known to probably be the first planet to form. This indicates that Jupiter could have sucked up most of the gas and dust that the Sun's formation left behind. Then the question, how much water did Jupiter suck? Did its moons take part in the evaporation of water? Answers to these questions would lead scientists to identify the most plausible theories to explain its formation.
And now we come back to the massive size of Jupiter, because scientists have discovered the effect it has on the whole solar system. Thanks to its massive gravity, Jupiter has been fingered for pushing planets Neptune and Uranus away from the Sun. This is due to a theory known as the NICE model, which claims that Jupiter and other gas giants caused a phenomenon known as the Late Heavy Bombardment, a time when the Earth and other planets nearby were bombarded with debris. However, that was in the past, as Jupiter now plays a mostly protective role to our planet. Jupiter helps to keep asteroids and comets from bombarding Earth, protecting the inner planets by acting as the vacuum cleaner of the solar system. The enormous gravity it generates can suck in and absorb smaller objects, like the 1994 collision of Jupiter and comet Shoemaker-Levy 9. Jupiter can also propel them out of the solar system entirely, but that same gravity can still accelerate some of those objects toward the inner planets too, so it's a mixed blessing. In all of this, you may be asking if there is a possibility of life on Jupiter. Well, according to scientists, if life were to be on Jupiter, it would have to exist at a height literally in the clouds, where the temperature is about 70 degrees Fahrenheit or 21 degrees Celsius. The studies suggest Jupiter has enough water to sustain life, so perhaps one day we... Apart from the Great Red Spot, Jupiter is known for its violent weather patterns. If you have any business on the planet, you must get ready to cope with wind speeds of up to 100 meters per second or 360 kilometers per hour. That would even be the norm, as winds can get as fast as 620 kilometers per hour. Storms form within hours and can become thousands of kilometers in diameter overnight. Over time, scientists have discovered 3 forms of radio signals emitting from Jupiter. These are decametric radio bursts, decimetric radio emissions, and thermal radiation. The first type, decametric bursts, vary with the rotation of Jupiter and are influenced by the interaction of Io with Jupiter's magnetic field. The second type is decimetric radio emissions, which have been traced down to a torus-shaped belt around Jupiter's equator. They are caused by cyclotronic radiation from electrons that are accelerated in Jupiter's magnetic field. The last one, thermal radiation, is produced by heat in Jupiter's atmosphere. Visualizations of Jupiter using radio telescopes have allowed astronomers to learn much about its atmosphere, thermal properties, and behavior. In mid-2021, NASA released a 50-second audio clip at the American Geophysical Union AGU meeting. Hold up, what? 50-second audio is definitely no joke. Could it be that some aliens are planning to invade Earth? The audio clip was gotten from Juno's Ganymede flyby. It was generated from data captured on June 7, 2021, during the spacecraft's closest pass yet to Ganymede. The sound was similar to that of a robot or a dial-up modem. This discovery joined the list of fascinating discoveries of Jupiter alongside the presence of water molecules. The audio was captured by Juno's WAVES instrument, which was designed to measure radio and plasma waves detected in Jupiter's magnetosphere, the bubble of charged particles that envelop the planet.
Commenting on the audio, Scott Bolton said, "The soundtrack is just wild enough to make you feel as if you were riding along as Juno sails past Ganymede for the first time in more than 2 decades. Scientists are still studying the wave data collected during the Juno flyby and attempting to decode what frequency changes are present within the recording mean."
Now, here is a piece of scientific discovery that might shatter everything you thought you knew about Jupiter and even the solar system itself. While you might have seen a million pictures of the solar system showing all the planets orbiting the Sun, and yes, we have mentioned Jupiter orbiting the Sun in this video, technically, Jupiter doesn't orbit the Sun. It actually orbits a spot in empty space between it and the Sun called the barycenter. This is because the Sun doesn't just exert gravity on Jupiter. Jupiter is so big that its own pull affects how the Sun moves too. While the Sun is about 1,000 times more massive than Jupiter, the two bodies affect one another proportionally according to distance and mass. This means the amount of Jupiter's pull on the Sun is 1,000th the amount of the Sun's pull on Jupiter. The Sol-Jupiter barycenter sits 1.07 times the radius of the Sun from the Sun's center, or 7% the radius of the Sun from the surface. The Sun also orbits this spot. If you were to look at the planetary plane from above, you'd notice a slight wobble as the Sun moves around the Milky Way. The next discovery involves an incredible similarity between the Earth and Jupiter. Look at the images below. Do you see the eerie similarities between the two? One image was taken on the Earth, while the other was taken on Jupiter, yet they look frighteningly alike. So what is going on here? On the left is a phytoplankton bloom in Earth's Norwegian Sea, while on the right, you are looking at turbulent clouds in Jupiter's atmosphere. Here is NASA's explanation. The simplified model of Jupiter's pole shows that geometric patterns of vortices, like those observed on Jupiter, spontaneously emerge and survive forever. This means that the basic geometrical configuration of the planet allows these intriguing structures to form. Although Jupiter's energy system is on a scale much larger than Earth's, understanding the dynamics of the Jovian atmosphere could help us understand the physical mechanisms at play on our own planet. Oceanographers have used Juno's images to study the turbulent atmosphere at Jupiter's poles, helping us understand the forces that drive the storms there. Did you know there is lightning on Jupiter, even though there is nobody there to see it? Stormy weather rules Jupiter's atmosphere, and this has made astronomers long assume that there would be lightning. This was confirmed in 1979. However, what they didn't envisage was how strange the lightning would be. Lightning releases radio waves, and for decades, every probe that visited the planet recorded something unusual. Lightning on Jupiter only signaled in the low frequency range, and no known theory could explain why, as Earth's lightning emitted radio waves from low to very high frequencies. However, in 2018, the Juno spacecraft finally solved the mystery. As it turns out, the problem was not with Jupiter, but with the limits of human technology. The case was simply the previous spacecraft could not match the sensitivity of Juno's equipment or get as close to Jupiter as Juno got. Not only did it record megahertz strikes, but some even zinged around in the gigahertz range. Intriguingly, the probe also confirmed that Jupiter's lightning was nothing like the ones on Earth. Lightning on Earth avoids the poles and prefers to zap the equator. The gas giant's equatorial zone has no lightning. Instead, it lights up Jupiter's poles with a peak frequency of 4 volts per second. Auroras are some of the most strikingly beautiful natural phenomena on Earth. Jupiter boasts the same amazing phenomenon. This is courtesy of 4 of its moons. When in close orbit, the moons influence something that scientists call plasma. When perturbed, this layer of charged particles triggers the auroras at Jupiter's poles. But to see this spectacular light show, you need to be equipped with ultraviolet and infrared equipment. In 2017, NASA's Juno spacecraft captured the closest view of Jupiter and took images of what you can call the moon's auroral footprints. The results showed something unexpected, but that was to be expected as Jupiter is always throwing up surprises. Previously, the patterns were considered simple and random, but the researchers discovered that the swirls were complex and unique to each moon. In particular, Io's contribution stood out. Scientists predicted a plain big spot, but what they got was a footprint with a tail that spawned its own vortices. Ganymede, the only mean with its own magnetosphere, also triggered something unique.
twin footprints. The double auroras are probably the offspring of the Moon's magnetic field inside Jupiter's, but scientists cannot begin to explain Io's strangely patterned auroras. Another discovery on Jupiter that has puzzled scientists is one that cannot be observed from the Earth. This discovery is linked to the planet's poles, which you need a spacecraft to see. What baffled scientists was that the cyclones encircling Jupiter's poles mysteriously arranged themselves in clusters with pentagonal and other geometric shapes. It was the visible and infrared images taken by the Juno spacecraft in orbit around Jupiter that revealed giant cyclones arranged in geometric patterns at the planet's poles. At Jupiter's north pole, one cyclone about 2,485 miles or 4,000 kilometers wide has 8 cyclones, each of a similar diameter, surrounding it. Coming to the South Pole, one cyclone that is about 3,975 miles, or 6,400 kilometers wide, is encircled by 5 cyclones ranging in size from 3,480 miles to 4,350 miles. Each of these cyclones lasted for at least 7 months. In each cluster, the cyclones were close enough to each other to essentially be in contact. This find reminded scientists of similar discoveries on another gas giant, Saturn. This second largest planet in the solar system has a single cyclone at each pole. This made scientists suspect Jupiter would have something similar. But of course, while Jupiter also has cyclones, they are different from what Saturn has. In fact, the scientists involved said it was a cautionary tale on making assumptions about a planet based on findings on another planet. But how they managed to last 7 months and managed not to merge remains a mystery. Even their geometric formation has not been explained. Looking at the image of Jupiter, some of the things that stand out include its stripes. While it may look like just another mark on the planet, scientists have found some amazing things about these stripes. For example, these stripes run more than 1,000 meters deep. Apart from the massive depth, they hold so much gas that their mass is about 3 times more than the mass of the entire Earth. Of course, these bands have been known for centuries, since Galileo pointed his telescope at the planet, but it's recently that scientists are getting to know just how deep these stripes are. This knowledge is all thanks to Juno. The spacecraft has provided a 3D picture of these stripes, allowing researchers to see the extent of their depth. Juno orbits Jupiter once every 53 days. As the planet's gravitational field tugs on Juno, it causes the radio signals that the probe sends back to Earth to shift a bit. The greater the mass under Juno, the stronger the gravitational pull the spacecraft and its radio waves experience. Now, because Juno's flybys are in different orbits each time, it can map the gravitational field of different parts of the planet. As Jupiter's belts of winds can flow at very high speed, they affect how mass is spread across the planet. What this means is that mapping Jupiter's gravitational field can shed light on how deep these winds really extend below the surface. The researchers discovered that these stripes extend 1,800 miles deep, or about 1/20th the distance to the center of the planet, far deeper than previously thought. These flows on Jupiter contain about 1% the mass of Jupiter. In comparison, Earth's atmosphere is less than 1/1,000,000th the mass of Earth. Apart from that, the data revealed that beneath the level of these winds, the planet's interior moves as a single body. In other words, it behaves as if it were a rigid solid despite its fluid nature. Prior work suggested this is because of the high pressures found within Jupiter. The hydrogen that makes up much of the planet separates into protons and electrons that generate strong magnetic drag forces that suppress winds flowing in opposite directions. Meanwhile, scientists have discovered that outside the solar system, planets can get even larger than Jupiter. The category of planets known as super-Jupiters has been expanding thanks to the discovery of exoplanets using the Kepler space probes and some ground-based telescopes. Hundreds of such massive super-exoplanets have been discovered so far. An example is the Methuselah or PSR B162026b, the very first super-Jupiter planet to be discovered. The planet is so named because at 12.7 billion years, it is the third oldest known planet in the universe. Also on the list are HD 80606b or Niobe, with the most eccentric orbit for any planet, and 2M1207b or Lerner, orbiting the brown dwarf star Fomalhaut b. And with the new James Webb Space Telescope in action, scientists are expecting to discover even more exoplanets. These may include more super-Jupiter planets. Let's hear your thought on planet Jupiter in the comments section below.